come back to the second example and the third example under the study of variable separation method from the idea of differential equation. Let's see how we can possibly solve problem of this nature and this nature. First things first, this one here is a concept or a problem or a differential equation under variable separation method. Why? Because I have the y over the x equal to a mixture of both x and y, or y and x, 1, 2. Now, what do we say you do? When it comes to variable separation method, we said the task is easy as move the term having y and the y to the left hand side. Move the term having x and the x to the what there? To the right hand side of the equation. That's all. My first task here, look up please. So it's easy. This y comes down here, the x moves here. That's all. More like saying cross multiply. That gives you dy all over. This dy is here. This y, bring it down here. Y is equal to this, the x. Replace this one here. That gives you the x over this x. We are here. What I think, multiply, right? And then you divide through. That you have be having this place. All right. The way I got this, let me show you again. I was having the y over the x to be equal to y over x. We said, because what? Multiply. The y times x gives you the yx equal to y times the x gives you y dx. So I want to make sure that y is with y, x with the x. So I'll first divide through by y. So divided by y, divided by y. This y cancel y. So I have what? The yx over y left to be equal to the x. I have the x here. Now I want to make sure this is the x. Move down here or move to this part here. It means that I'll multiply through by 1 over x. So 1 over x times the yx over y equal to 1 over x again times the x. This one cancel this one now. So I'm having what's left now? The y over y. So I'm having the y over y left to be equal to 1 times the x gives you the x over this x. That's why I have this. So to avoid at your level, to avoid this long process, you should know how to do this way. Please. Save time and stress. It saves time and stress. Alright. Take this part off. I just showed you in case. So some people won't get it right. So I showed you. I have to show you. Alright. Let's proceed. From here, your next task is to integrate through. Alright. Integrating through. That gives you the integral of dy over y is equal to the integral of the x all over x. Alright, well here. Next task here is that you shift them out. This gives you the integral of 1 over y with respect to the y is equal to the integral of 1 over x with respect to the x. I'm integrating 1 over y with respect to the y, which makes sense. I'm integrating 1 over x with respect to the x. Perfect. That's it, please. Now, if I integrate 1 over y, it's easy. If I integrate 1 over x, we know that I have ln x plus c. Similarly, if I integrate 1 over y, that gives you ln y. That's all. That gives you ln y. So I have this one here. I want to make y subject. What do we know? Now, watch this, please. Watch this. If I have log 32 to base 2 equals 5. This is logarithm. One of the relationship between indices and logarithm is that for logarithm, I have this. I want to express this thing in indices format. So bringing in indices, format, that gives you this 32 should come out first. 32 equals this base will now stand as a number here. This 5 comes as the power. So 2 to the power 5 is something as what? 32. You can see this. This is called relationship between logarithm and what there and indices. So here's the idea, please. If I have log something to base something equal to 5, this value can stand alone. This base becomes a whole number. This 5 here becomes the power. This is called relationship between indices and logarithm. Now look up. I just showed you in our previous example that ln means log of that thing to base e. Ln is log of base e, that's all. This y should come down here, no problem. Is equal to ln x plus c. I want to make y subject, that's why I'm going through this process. Now, now apply this analogy. Here, we said log of y base e. Log of y base e. Observe, see, this is y, this is e. We said the idea is that this one here, 32, comes out first. This y comes out first is equal to, we said this base here becomes a whole number. That gives you exponential. This one here becomes the power. This one here becomes the power. That gives you ln x plus c. This is how you solve this particular differential equation question. That's all, please. That's all. Please observe the math I'm applying here. This log and ln concept, please observe. Ln is log to base e. This y remains y here. Equals everything here is the same thing here. We said applying this idea here. This y comes out first. This e becomes a power, becomes a whole number this way, and this one becomes a power. So I have made y to be what? Subject this way. This is the required solution for this differential equation using the method of what? Variable separation method. Let's solve number 3. Let's solve number 3. Let's solve number 3. All right. For number 3 here, this is a what? A variable separable. Y, a mixture of both x and y is here. So what do you do here in this case? Let us first, it's easy and easy and easy. I'll cross multiply. So it means y times dy. That gives you y dy is equal to x squared times dx. That gives you x squared dx. Next task, integrating through. I'll integrate through, integrating through, I'll have the integral of y dy is equal to the integral of x squared dx. So in this case here, I'll be applying the general method of integration. So look up, please. Look up, please. If I integrate x with respect to the x, my answer becomes it's easy. This x is already having an invisible power already. So that gives you x. The power is there already. So we said the idea, let me this way. Let me put 2 here. Okay, let's put 2 there. This gives you x squared, x squared. We said if I want to integrate x squared with respect to the x, it's easy as repeat the x squared, add 1 to the power. All over, whatever you're having in the power, repeat it down, 2 plus 1, then plus c. This one gives you x cubed over 3 plus c. If you want to integrate, the idea is that for general method, you always add 1 to the power, and whatever is in the power, repeat it down as for the denominator. That's all. So x squared gives you x squared plus 1 over 2 plus over this 2 plus 1. This is how I integrate this general method. Apply that same thing here. If I integrate y with respect to the x, it means that this y has an invisible 1 already. Then we say what? Add plus 1 to it. All over whatever you're having here, that's 1 plus 1 should come down this way. As said here, is equal to, I've just done this now for you. So what's my answer there? S cubed. That's S cubed over 3, then plus what there? Plus C. So right here, please. Let's proceed further. Take this one off. Let's proceed further. All right. From here, that gives you y square. Y square over 2 is equal to S cubed over 3 plus C. All right. We want to make sure y is subject formula, right? Because we're trying to bring back the value of the x to y. So in this case here, what happened in this case? I'll use, okay, perhaps I can say multiply through by 2. So multiply through by 2. I want to take this 2 here. So this is as multiplied by 2. That gives you 2 times everything here, y squared over 2 equals that same 2 times everything in the other side, x squared over 3 plus c. This is called multiply through by 2. Multiply by 2 by 2. So these 2 cancel this one here. I have y squared left. Y squared is now equal to 2 into s squared. Sorry, is it s squared or s cubed? S cubed, please. S cubed. S cubed over 3 plus c. All right, I have this one here. Yet, multiply through. Let's see what we get. All right, from here you have y square. Y square equals, this one gives you 2 times s cubed gives you 2s cubed all over 3 plus 2 times c gives you 2c. All right, we're here. What we know is that if I have, look up, if I have 5 equals, so yes I did, if I have 5 and equal to, if this 5 come here becomes negative 5. If I have minus 5 here, is minus 5 cross equal to equality sign gives you what? A plus 5. Similarly, if square cross other side gives you a square root. So you have y equals square root now. Y square root, because a square crosses equality sign to the other side gives you square root, equals what there? 2s cubed over 3 plus 2c. This is the required solution for this differential equation question. Then I solve this third example using the idea of variable separation method under the study of differential equation. Let's proceed to our next example, which is example 4 in our next video.
I just launched a book called The Shortcut to Academic Success. In this book, I share a lot of experience on how I evaluated during my time in school. This method really helped me a lot. If you're interested in getting this book, simply chat me up through my WhatsApp number that is shown in the screen. Alright guys, you can now join my channel membership to have access to exclusive videos of mine which most people will not have access to. To get this link, this membership program, as you can see the left hand side of the screen, You can see the YX/JAM classes. You can go there. It of course 1,000 naira, or you go for the other level student to have access to both. Right. So once you join the channel membership for other level student, you will have access to both the WAEC and the JAM classes with the other level itself. So do well to join this membership to support our online academic session. See you guys sooner. Guys, I just launched some courses on my website. These courses include physics tutorial for year 1 student, YX/JAM student, YX/JAM classes for JAM student, and also I have the organic chemistry for beginners. So these courses, you can get these courses on my website, as you can see displayed at the right hand side of the screen.